Yeah, so as you can see today, I'm going to talk about DALL flow when neural search meets generative art. So before that, I actually didn't know that Timo before me had a similar talk like this, right? But I think I can put it into the next level, right? So I will introduce a lot of new technologies, new terms to you. To be honest, it will be a very compact talk, right? So you will have a lot of knowledge, but I hope that after this 30 minutes, not only you can understand how this generative art, but also understand how the relationship between neural search and generative art, but also you can generate your own artwork, right, using open source software immediately after this talk. So to be clear, what we are talking about is something like this, right? So you have a program, AI program, that your input is a text prompt, right? So for example, the ocean beach front view in Fango style, right? That's it, right? No initial image, right? Your only input to this almighty program is the text, is this sentence. That's it, right? On the right-hand side, you found this very nice artwork. This is text to image, right? So this is what we are going to talk about. Right? There are also other examples like the Statue of Liberty wearing a VR headset, which is pretty funny, right? And there is also a very romantic one, like a painting of a couple kissing in nebula, right? So after my talk, after 30 minutes, you are able to generate such artwork by yourself, right? So a little bit short intro about our company. We are based in Berlin. We founded in 2020. We are Gina AI. Right now, we have 50 members, headquartered in Berlin, but we also have offices in US, in China, and also other people from Spain and Greece. We raised a lot of money over the last 2 years, so we are one of the really top-tier AI companies in the world. Right? So we are ranked by CB Inside AI 100 in 2021 and 2022. So what do we do here is we create the technology called neural search. The idea here is, one of the topics that I'm going to cover today. And we are also a very active contributor to open source, right? So which is very sexy, very nice, right? So we provide a lot of technology stack for you, for developers like you, to build neural search, this technology, into your applications, right? End-to-endly, right? So from the idea, from the moment that you have this idea, to prototyping, to implementing, to deploying, to monitoring, to analyze the search result, right? Everything is in our tech ecosystem, is in our Gina ecosystem, right? But that's not the, we will come back to these slides afterward, right? So today I want to cover these 3 topics, right? The first is about neural search, and then second is generative art, basically the OpenAI, DALL, and Google image gen, all these kind of things. I want to put it in this way. I want to bring some connections between these 2 terms, right? So neural search and the DALL things, right? So what is the connection here? For people who study machine learning before, right? So you know that in traditional machine learning there is discriminative AI and generative AI. What is a typical example of discriminative AI, right? Like nearest neighbor is discriminative, right? And what is a typical example, classic example of generative AI? It will be naive Bayes or Markov chain. It's kind of generative, right? So let's first talk about neural search. So what is neural search, right? The idea of neural search is actually nothing so so recent or so sexy, right? So for example, there is one very good example. You want to search a sentence inside a book in a very fuzzy way. So basically, you can imagine you are basically building a grep, right? Linux grep tools. But the searching is not exact match, but it's kind of fuzzy match, right? So you want to search for she smelled too much, but it could be also like she laughed too much, she smelled too often, all these kind of variations. It's totally okay if you can retrieve, if your program can retrieve such variations from the text, right? From the textbook. So basically, your input would be she smelled too much, and then our output could be some sentence like this. So with Gina doc array, which is data structure for unstructured data, you can easily do this in just 14 lines of code. So you can easily build your fuzzy version of the graph in just 14 lines of code, including download the book, split the sentence, apply this, do some very easy or simple feature hashing, and then build the query and then search for it. Right? 14 lines of code, easy peasy. And then there is another very good old cliche, like you take a photo of some guy, some dress, and then you want to search for this photo inside the database, which is a pretty common, let's say, scenario in the e-commerce system, right? So you want to have this shop the look things, right? So also with Gina, you can build such things in just 25 lines of code with the state-of-the-art pre-trained model, right? So everything is super easy. Right? And let's bring this difficulty to the next level. Image is very easy to solve, but how about 3D mesh, right? So this comes from the real-world example where one of our clients, they are trying to build developer tools on top of Unity, right? So for those who play games, 3D games, you know that there are a lot of games are built on top of Unreal or Unity engine, right? And so this guy have kind of an asset store, in their database, right? So this asset could be game asset. It could be 3D mesh, visual effect, sound effect, particle effects, all this kind of thing, right? So they want to implement something like, they drag and drop a dinosaur into the scene, right-click on the dinosaur, and then they can look up all the similar monsters, from their asset store, right? How are you going to do this, right? So this seems like a little bit difficult than previous static images, right? So the other example is our good old chatbot, right? So which is a question answering. But here we're talking about closed domain question answering. So one very good example that is also powered by Gina is the chatbot on FastAPI website. I don't know how many of you know FastAPI. It's a very popular Python web framework. If you go to their website, on the right corner, there is a chatbot, and then you can ask all kinds of questions as long as they can be answered given this technical documentations of the FastAPI, right? So it's kind of like a closed domain question answering chatbot. It cannot do the flirting with you. It can only answer the questions, the technical questions from the technical documentations, right? So this is also an example of neural search. Right? As a summary, right? I don't want to go into very details because there are a lot of applications of neural search. But in summary, what is neural search? Right? Neural search is about using deep learning to do information retrieval on unstructured data, right? So imagine you have a lot of modalities, right? So that neural search is about exploring the relationship between different data modalities, right? The important part here is the data is there, right? It is there. And the relationship is not there. And then you want to build up the relationship to use this relationship to find the data in the same modality or in another modality. So this is neural search, right? So remember this graph. We will come back to this figure later when we talk about generative art. OK, so is neural search solved? Right? Is neural search solved? Actually, no. Right? So there are a couple of fundamental problems, including how do you measure the semantic? How do you store those semantics as a vector, into the vector database? How do you? What are the other difficulties? How do you generalize into different, granularity and so on? The most important thing about neural search is actually not about all these academic problems. It's about how to bring this neural search into production. Right? So we talk about semantic search, we talk about neural search for a couple of years, right? But look at how many systems in production actually using neural search. Not so many. How many cloud-native production systems really use neural search, right? Not so many, right? So this is a real problem. And Gina, we are here to provide a full-stack solution to help you, build up neural search in production, right? So comes to the next topic. What is DALL and diffusion? Now we are talking about generative art. I think Timo in the previous talk also mentioned a little bit about DALL, although he's mostly focused on the GAN stuff. So this is DALL. DALL is some OpenAI created, mighty AI published in 2021. And then this year, it also announced this DALL 2, right, which is an improved version of DALL, right? To understand DALL is not easy. Let's be honest, right? Because most of the reason is that DALL-E is not open source. It is a gray box, right? It is a gray box. There's no source code. OpenAI doesn't release the source code, so all you can do is just reverse engineer, based on the OpenAI blog posts and also published papers recently, right? So fortunately, there are a lot of YouTubers explain DALL-E pretty well, so I strongly recommend you to watch them if you haven't, right? To understand DALL-E, sorry, in my opinion, right, you have to understand 4 technologies, right? So those are the 4 pillars in order to understand how the DALL-E works, right? You have to know about BERT, which is a Google AI technology back in 2018. You have to understand VQ-GAN, right? It's a variational autoencoder, right? Also published by Google in 2018. You have to CLIP, right? The cross-domain retrieval model published by OpenAI. You have to understand diffusion, also published by OpenAI in 2021. As long as you read those 4 papers, you are now ready to go to understand how DALL-E really works. I want to explain, very in details how DALL-E really works. I will just briefly describe what is happening between DALL-E 1 and DALL-E 2, right? What is happening between this, in the last 2 years. Originally, DALL-E 1 is powered by CLIP model, right? So you input a sentence, you use CLIP model to translate the sentence into an image vector, and then you use some kind of decoder to, recover, to reconstruct the image from this image vector. But then, people found out that, okay, so I can add something called diffusion prior in the middle to translate this back to the image space and then directly decode this into image space, which gives a better quality in general, right? There is a, sorry. By the way, is this my water? I don't know. Okay. So there is a very good open source software which is called Clip as Service, powered by Gina AI. So you can go ahead and look at it. So this also serves as the foundation of DALL-E Flow, which is basically the open source frameworks that we are going to talk about, right? Okay, cool. So I talk about diffusion, right? How many of you knows what diffusion means, right? Diffusion in physics, it means thermal physics, all this kind of entropy, all these things. But in machine learning, diffusion means a Markov chain where you keep adding Gaussian noise to the original pictures, right? Until the point that you cannot tell, this is a dog, right? So you add too much noise to this process that you cannot really tell what the original object is. And then diffusion model basically build a lot of neural networks, try to recover this the original dog, the original picture from the random noise, right? So you can imagine for each step, I have to figure out, I as a neural network, I have to figure out what is this, lousy Gaussian noise is. I try to recover the original picture, right? So therefore, for this purpose, diffusion model is always is commonly used for upscaling, right? For upscaling, because it can always give you better quality, image quality, right? So this gives you an idea how the DALL-E compares to the diffusion model, right? So I'm not sure if you can really see the details, but diffusion model, you can use DALL-E as the input and feed to the diffusion model. This diffusion model will improvise on a lot of details and makes those details very, much perfection compared to the original image, right? So this is also image generated directly from diffusion model. I generated, so it's kind of like a sci-fi thing. I forgot the prompt. This I remember the prompt is, a satellite shooting yellow beam lasers, try to destroy the Earth, something like this. So it's very nice. So the quality, you can see the image quality compared to the DALL-E one is completely on the next level, right? So there is also some alien technology stuff. I love to create those sci-fi scenes. If you compare this DALL-E and diffusion side by side, right? So you can see DALL-E is much faster. Diffusion is slow because it's Markov chain, right? So you cannot really skip the step. One step has to depends on the previous step, right? But in terms of the quality, DALL-E is suboptimal compared to diffusion model, right? Okay, so now comes to the very important step. Now come to the how can I put the neural search and generative art into one umbrella, right? So generative art is actually a deep learning powered content generation across different modalities, right? So for example, you can imagine GPT-3, you use text to generate text, and for DALL-E, you use text to generate image. So the difference here is in generative art, the data is missing, but the relationship is there. And then you try to use this relationship to generate data, right? Instead of trying to find some data, right? So if you put this side by side, you can see the difference, right, and the connections. On the neural search side, you can see the data is there, but the relationship is not there. So you are trying to build up the relationship and try to find the data from either this modality or from other modalities, right? On the generative art side, the data is not there, but the relationship is there. So you can use the relationships that you learn from elsewhere to generate data, either inside this modality, such as GPT-3, or outside this modality, such as DALL-E, right? And these two things together sit under the same umbrella, which is called cross and multimodal applications, right? And this is what we are doing at Gina AI. So to understand how Gina technology stack works, right? Today I will just give you a very short example, which basically starts from the three basic elements of document, executor, and flow, right? So to see this very clearly, I don't know how many of you speak Python, but this is a very simple Python program that write in 15 lines of code, right? So in the first line, you import the Gina document, Gina, there's all this concept. So as I said, there are three basic concepts in Gina: document, executor, and flow. These are very three fundamental concepts. And then you build an executor. So executor is just a kind of a function that works like a microservice, and we will see that later. And the flow is kind of orchestration. You connect all the executors together to accomplish a big task, right? So in this case, we just keep adding 2 executors to the flow. And finally, you can use flow as you open a file, right? So you open the flow and then write something, send the flow, and then you retrieve the result. 15 lines of code. If you run this code, it will give you such result, right? So you can see, oh, there's some gRPC server opens up, microservice port, explodes, all these kind of things, right? And finally, it will print you the hello, hello world, this result, which is totally reasonable. And then the natural question is, okay, so you point out something like this, right? So, but it seems to me I can use standard Python to accomplish the same thing with just 12 lines of code. Well, you have to use 15 lines of code, 3 extra lines for what, right? So this basically is a question for a lot of developers to, they want to ask, what is the benefits of using Gina framework to build neural search or to build cross-modal and multimodal applications, right? And this is the benefits, right? The benefits comes from the replicas, the sharding, the scalability. The benefits come from the duplex streaming, comes from the async non-blocking data processing, comes from the gateways that automatically support gRPC, WebSocket, GraphQL, HTTP, come from the, the microservice, Docker containerization, come from the observability brought to you by Prometheus and Grafana, right? So all the cloud-native features is compressed in these 3 lines of extra code, right? So to understand Gina, when you first look at Gina, you will find out there are a lot of abstractions, there are a lot of layers in between, right? So inside Gina, there are from the bottom, you have the network layer, and then on top of that, you have the logic, you have the data layer, you have microservice, runtime, orchestration, and finally to the applications. As a developer, right, all you have to care about is it's the 3 layers I pointed here, right? If you want to build a cross-modal and multimodal applications, you only have to care about the data layer, the logic layer, and finally the orchestration layer. That's it, right? So these 3 layers nicely corresponds to the 3 components that I just talked about, the document, the executor, and the flow, right? So as a bonus point, I want to give a short intro about the cloud native. This is not KubeCon, but let's say I want to throw this teaser, choose a cloud native framework here, and there are 4 options like TensorFlow, PyTorch, NumPy, scikit-learn. So which is a cloud native framework? You can choose, and then I will review the answer. None of them are, right? So this is a trick question, and in order to, to make your framework or software cloud native, you have to at least, enable those 4 pillars, right? So like orchestration, microservice, or containers, observability, right? So those are the 4 fundamental things in cloud native structure, right? So then why do we have to marry the neural search with cloud native? Are you trying to bring something sexy, but it's not really needed in reality? Right? Actually, there are a lot of good reasons. Here I summarize the top 3. Right? So first of all, when you try to build a neural search or cross-model applications, usually you are not handling single task. You have a lot of pipeline of tasks, right? So this very nicely corresponds to the microservice architecture, orchestration, all these kind of things. So secondly, when you try to build neural search application, you always have to install a lot of very complex dependency. How many of you give up on machine learning or artificial intelligence after installing CUDA drivers for 3 days, right? I believe there are plenty of them, right? So containerization is a very nice strategy, a nice solution to solve this very complicated software dependency. And finally, neural search is often used not as a consumer application, but as an infrastructure. Usually when we talk about infrastructure, we want it to be robust. We want it to be stabilized, right? So therefore, the DevOps CI/CD observability is definitely one of the pillars in this cloud native. So in summary, so what the Gina do is, initially, when you try to build an application, cross-model and multi-model application, your starting point is from there, right? From the 0 point. So you move vertically, you move horizontally, you try to bring TensorFlow, PyTorch, Onyx, all this kind of thing, and build a POC, right? So you move horizontally to the local to build a local monolith prototype, right? And then you go vertically, right? So you want to scale it up, you want to serve the real customer, you want to serve the real HTTP requests, and so on, right? So you want to make it production ready. So Gina here is basically help you, or Gina ecosystem here is basically help you to move faster to the production ready. Right? And of course, your respect from your ego engineer friend. I pointed it out here because usually people start building cross-model and multi-model applications, they usually come from the data scientist background, right? So therefore, a lot of engineers, they don't really care about your data science things, and they want to be, cloud native, all these kind of things. Right. Okay, finally, we are able to talk about DALL flow, and then we have 2 minutes left, perfect, right? So quick facts is a DALL flow is actually just weekend work built on top of Gina and all the ecosystem to basically to show you that we are able to easily build very let's say very advanced project cross-model multi-model applications in just a couple of lines of code. Right. So if you look at the code, the major part of the code is actually a YAML file, which basically defines how this DALL diffusion actually works together, right? And if you break up the YAML file, you can see that on top of the YAML file, you have some flow configuration, and then each part of the rest part of the YAML is they are used to specify the executors, and each executor corresponds to some Python bundle trying to represent a model, right? And then finally, you can bring all these things together, each one of them as a container, and then you can use Kubernetes, you can use Docker Swarm to orchestrate everything. Or if you choose not to, you can also use the native Python to orchestrate everything, right? Okay, so finally, we have 1 minute left. I want to show you, by the way, so this is how the DALL from server side looks like, right? So DALL flow is a client-server architecture, right? So we're talking about how do you make a DALL server, but how do I connect? What is the user experience? So I want to show a Google Colab here, so basically to give you an idea. So you can also go to our repository, DALL flow repository. You can also go to this repository and click on this, click on Open in Colab, and then you can generate your own artwork, right? So you start with, you open this notebook, and then you can input your prompt here. The prompt is, since we are developer meetings, developer conference, I wonder, what is the old days of doing this? Like, I wonder what is the historical photo of ancient Greek scholars doing pair programming on their laptop, right? So I input this prompt, and then I get the 16 candidates, from the DALL flow, right? So the 8 generated from DALL, the 8 generated from diffusion, and then we re-ranked it using clip-as service. So that's why you see the top photos are making more sense because it's ranked by clip-as service, right? So my remaining task is to select which one is, looks best for me. So I think that this one looks best. It has this chest, naked chest. It looks like very grace, right? And but this thing is not very perfect because if you look at the details, the face is not perfect, right? So I want to diffusion. I want to do another round of diffusion. Remember, I said that diffusion is about making details more perfect. So I hope that by sending this image to the diffusion model, I can have more like a realistic face. So I send this image as initial image to the diffusion model, so I get this different, kind of like improvise over my initial image. And then I think that this image is pretty nice because it has kind of face. I mean, you don't have to be very crystal clear. It's an Asian photos, right? It's an Asian photo. So you don't have to be crystal clear. And then, so this is my final image. And then at last, I upscale it, right, to 1024 by 1024. By the way, so the original output of the diffusion model is 256 by 256. So that's why the last step is to upscale it into a better quality. It's also used, deep learning. And that's it, right? So you can have the historical photo of ancient Greece pair programming on the laptop. And that's the end of my talk. Thanks.
Many, many thanks for that enlightening talk. I mean, yeah, there's a lot of things possible with multimodal and cross-modal machine learning. So far, I have not seen any questions in the Q&A tool, but I'm a bit suspicious because it failed during the last session. So if any of you feel inspired now to ask a question, I'll just come to you with the microphone and you can ask directly. Yeah. So,
thanks for the talk. Steffen, my name. Currently, I use Elasticsearch for information retrieval on text document data.
Yeah.
So we get, let's say, an accuracy of 90% of the top one correct answer. So, how do you have any metrics how good Gina AI is on this task?
Yes, I think so. The question is, a lot of people using Elastic as their text search solution, right? So it's kind of their legacy system is already built on top of Elastic. So the question is whether Gina AI want to replace it or want to be a partner of it, right? So kind of like, oh, do you want to improve over Elastic or something like this? I think my answer to that is the traditional search brought you by Elastic or Lucene or Apache Solr is what we call symbolic search. It's what we call symbolic search. So it's based on characters, it's based on TF-IDF, BM25, all this kind of thing. It has no deep learning involved, right? So it has certain advantages, right? It's very mature. It has been studied over the last 20 or 30 years. But the problem is that it's not very smart, right? The neural search part is very smart. A lot of times it will surprise you, but the problem is it's very slow, right? It's not very scalable, right? And it's sometimes a lack of interpretability, right? So in Gina AI or Gina framework, the mission here is to accomplish, right, to complement the existing Elasticsearch stack, right? If you are working with the text domain, right, so you can think Gina as your friend, right? But let's say if you work in the cross-modal and multimodal domain, which Elastic cannot do at all, right, then Gina should be your primary developer tools, right?
yeah, so if there is another question, we have time for another question here. If that is not the case, then I will say thanks a lot again, dear Han. And yeah.